Bismillahirrahmanirrahim. Good afternoon. I would like to introduce my presentation about non-conventional water resource in Egypt, wastewater treatment experiment that implemented by National Water Research Center. I have divided my presentation about 5 parts. The first part about introduction, then background, about previous studies from wastewater treatment, and explain in brief compact treatment plan, and finally the recommendation. Let's go to the first part of my presentation about introduction. The demand for water will increase with population growth. The process of reusing water will become more important in future because the limitation of water resources and the reuse of wastewater is one of the main non-traditional water resources. And finally, the most serious threat of reusing wastewater is the pollution. Let's go to the second part of my presentation, background. Drainage water treatment using cactus is one of water treatment methods used in many countries and Egypt. Cactus may be a useful material for wastewater treatment by coagulation instead of chemical coagulation. NWRC implemented a project studied the effect of cactus in improving water quality, and all analysis in Central Laboratory for Environmental Quality Monitoring. The project is a part of the STEM school project. So the main objective of the studying the effect of different concentration of cactus on wastewater and the determination of the optimum condition for using cactus in water treatment. As we show the field and the laboratory measurement, we use 9 glass aquaria for water treatment as a small experiment, collecting, peeling, drying and grinding of cactus, and preparing of sand and carbon filters, and adding the sewage water in the glass aquaria after passing through sand filter overnight about 24 hours for removing the impurities before adding the cactus. And we use the 4 concentration of cactus that is from the previous reference, scientific reference, from 0.5 milligram cactus per liter to 3.5 milligram per liter. Of physical, chemical, and microbiological parameter of collected sewage water sample before and after treatment. As we show, the different parameter, concentration, and the removal efficiency, that is the 1.5 milligram per liter cactus is the optimum, and the maximum concentration is the in removal efficiency of all parameters. As we show, a total suspended solid, ammonia, BOD, COD, and most of heavy metal and the microbiological parameter may be above 80%. In conclusion, according to sewage water analysis, it was found that the cactus improved water quality, and the optimum treatment was monitored using the second treatment 1.5 milligram per liter. Although the efficiency of purification by using cactus and raw material as sand and gravel, it is difficult to apply the use of cactus on large scale. Therefore, another method of wastewater treatment that is applicable to a large scale has been considered, and also economical. That is the wastewater treatment using compact treatment plant. Research team from Channel Maintenance Research Institute, which follow National Water Research Center, established an integrated wastewater treatment plant with the research test area of Kilikam as a guideline model to benefit from the wastewater resulting from three administration buildings. Video film show overview video film show overview of treatment plant. So the main objective of the plant is divided into 3 phases. The first phase is the aeration phase, then sedimentation phase, then filtration phase. Let's start with the aeration phase. This phase is processing in a tank with a capacity 50 cubic meter. It contains 2 pump stations and the pipeline network. The mechanism of aeration phase: after filling the aeration tank with sewage water, the pump operates and start to pump out of wastewater into the piping system. The piping network has different lengths and diameter that range from 25 millimeter to 75 millimeter of pipes. As is increase the mixing air with the sewage water. The aeration process takes about 8 hours. That is the retention time for the first phase. After finishing the aeration phase, the treatment water moves to sedimentation tank. As we show, this video explain how to increase the aeration system by using a network system. The second phase is the sedimentation phase, which contains 2 weirs, a PVC sheet, 1 large pump, and 2 pipes with a diameter 100 millimeter. And the mechanism is sewage water flow into the sedimentation tank through inlet pipe and settle down on a weir. The sedimentation process takes about 4 hours. The sludge pump operates when the sedimentation increases and transfers the high density of sediment to the aeration tank to re-treatment again. And another pipe located at the water surface level is function to control the flow velocity. The wall and the water is transferring through these walls until the infiltration water pumps out of the irrigation tank. The filtration phase, the wastewater treatment before and after process. From the initial result, the water sample peak from all phases and analysis in the central laboratory for environmental quality and monitoring. The retention time of all parameters may be more than 80 or 90% from when compared with the raw water to the outflow. That is the all parameter and heavy metal, and especially the total fecal coliform and total coliform. That is the outflow. That is the improved maybe 90%. In conclusion, indicator of the initial result of the new treatment plant shows the efficiency of this process. The small size of the construction area required for the plant compared to the central treatment station, and it is expected economically when applied in the villages in Egypt. The idea of integrated wastewater treatment, depending on the method of direct ventilation, extended with the ability to use low-cost raw material in the treatment of wastewater for use in the irrigation of green area. And finally, the recommendation we recommended need more studies about using different filtration material as chlorine tablet, increasing retention time of passing water across different stages to improving water quality. And up to now, the sediment have not been withdrawn, but in future, the teamwork will use the sediment resulting from the process of treatment in the production of biogas and compost. And also recommended the Ministry of Housing can apply this model in future in and careful.
Thank you. Still have some problem. I cannot share my presentation. So, is there any reason I can share my presentation? I'm asking the moderator, the host. Okay, so I should move to so I can start there because I cannot share the presentation for you. Huh? Okay. Yeah, sure. Today I'm going to present the DSS tools for protection for Red Sea shoreline against climate change impacts. Actually, this project started from 1 year ago. The main objective of the project is to decide the shoreline backline for the Red Sea. Okay. I'll try to raise my voice. Actually, this project is made for the Shoreline Protection Agency. It's 5 institutes have been participating in this project, which is ECRI, Environmental Climate Change Research Institutes, Coastline Research Institutes, Survey Research Institutes, and Water Resources Research Institutes, and اوكي معلش الصوت مش هيطلع لحد صوت الدكتور حسام كان مش طالع. اوكي that's fine. So we start this like almost like one year ago. the main decision tools use some parameters to explore, so we can decide the shoreline protection, which is the sea level rise projection for 2050 and 200, climate change regarding participation temperature for 250 and 2050, 2100, geographic area, land use and cover, high water level, hydrological data, and environment. The area for the Red Sea have been divided to 5 almost equal zones, so it can be more manageable, and also we can learn from each part according to the characters. More than 16 images for 2013 and 25 satellite images for 2070. Those are spot satellite images that have been bought, so we can see the area there, the development area, if there is some projects that we can consider in our shoreline protection line. Actually, this satellite images are very high resolutions, 1.5 meter panchromatic and 6 meter resolution multispectral. It have been processed so we can get much more information from the past, with 2013 and 2017. The images have been processed, so we can get the pan sharp with 1.5. So I can see this in the pictures, the core reef in some area, the sediment in some area, and the development from one place to another. Actually, the first problem was how to decide the shoreline. It's the wave breaking or the weighted line. As you can see in these pictures, there are like 3 lines there. The breaking line for the waves, the inference coastline, and spread line from dry and sand, which is a wet sand. And actually, it applies the normalized different water NCs. So we can decide this for the whole 5 zones. This area, the models work actually good, especially with the spot satellite images and with high resolution. So this have been developed using the multispectral images, and later the band sharpening have been used to modify. The line have been extracted from the model, since there was in some areas there was some lagoons that water line there. It's located, but it's not part of the shoreline. Actually, most institute did a lot of work in this area. As an example, Survey Research Institute in zone number 1 only collecting 480,000 points for elevation, which are going to be used for the digital aviation model. Coast Research Institute actually did a great job in most of the zones. For like zone number 1 only, they collected 135 points to making the bathymeter for this area. This data have been collected and have been studied to explore the outlines, spatial dependency, and we see how it's close for the dust distribution, so we can find that good method for interpolating this data and creating the service area in a good representative for the shoreline. Actually, NUDIM have been selected because its ability to produce an accurate map that's interpret hydrological correct surface from points and lines. The capability of natural grace actually have been acquired in research for 2013 to prove this is going to be the best method for generating the surface using these points, especially for water analysis or water flood analysis in this area. Different dams have been generated, or actually dams have been generated for the 5 zones. Contour lines have been generated for 10 meter, 20, 25, and 50. The same thing for bathymeter have been produced for 5 meter, 10 meter, 15, and 20 and 25 for each zone, and have been generated. All this going to be put in the database, as I'm going to show later. The projection for temperature for 2050 using RCP scenario 4.5, and for 2018 for 8.5. And here is the rainfall for 2050 RCP for 4.5 and 2100 for 8.5. All this data we're going to be put in the database, so it can be a tool later for determining the shoreline or not shoreline, the break, the setback line from out of the 28 global distribution model. It have been selected the most accurate one or the most suitable one with the data we have. So we can project the 2050 and 200 seawater live, which are going to be 77 centimeter and 106 centimeter. Also, biodiversity have been considered for all the zones, have been collected by ECRI. The hydrograph have been made for different places to check the core reef is there and how much the depth and the type. The types have been collected from all the five area. The depths for each, the type and the depths for each type and zone have been collected and maps have been generated. The protected area have been collected from EAA, which we're going to present the areas shouldn't be touched or should be protected. Water research, Water Resource Research Institute have been actually did a good work for creating the natural streams, the outlet of the shoreline of the watersheds. Also provide with the geological map for this area. Official maps also have been provided by WRRI and also have been putting in the database as can be used. Okay, as a tool. Also, the land use for different areas. High water level have been generated by NWRC main quarter using actually it have been created by the Hydrological Research Institute and Dr. Khaled Hay, the president. The geodatabase have been selected for file database since it's multi-platform. It's also can reach to 2.56 terabit per table, which is not available for the personal and also for the enterprise. It was not the authority ready for this at that time. Different category have been done for each category of files like bathymeter, climate change, environment, hydrology, land use, satellite, high water level, sea level rise, and survey. Each one of these category have been made in the geodatabase and have been generated and put there. There are more than 1,286 maps have been generated and put in the geodatabase, so it can be used later for decision maker to create the setback line. Actually, here is part of the developed or the results of the geodatabase. This is the setback line for the area in Safaga and Garda, and it can be generated according to the scenarios that have been going to be generated by DSS. Thanks for all the teams in Survey Research Institute, in Coast Research Institute, WRRI, main sectors, and Hydrology. And this is my team for ECRI. I would like to thank him as well. Thank you very much.
Our next speaker is Dr. Jamal Assar. He is the Director of Water Management Research Institute. We provide experience for water projects in the Middle East and countries. We work with the irrigation, water management,
Thank you, Chairman. Okay. Okay, sir. Just as an outline of my presentation, as we said, we are going to introduce some of the innovation has been taken out using the water management and safe states stations. In the meantime, we are working very close with some of the field with the farmers. The institute is trying to help with the WRC, with the ministry to move from theory to practice application with such initiatives. We are going to talk about subsurface irrigation techniques. At the moment, as a mega project is running within the ministry, applying modern irrigation techniques in the old land, mainly, and some test studies have been done in partnership. The integrated farming system to introduce fish farming with the crop production using the same source of water to improve the return per unit of water. Some techniques regarding cultivation need how it deals with water management issue. This is our main topic as to help with the distribution of water within these areas. City techniques has been initiative introduced for such cultivation. And finally, we are going to talk about the unconventional water resources, where to use the low quality water within the saline soil to have some new techniques to use it within a new station has been given to the institute and some way forward. As an institute, just as the chairman is mentioning, we have four main departments. Just I'm going to talk about the department, but mainly each department has got a topic. One is the field management to work with farmers. The other monitoring and evaluation, which now covers the mega project running at the moment with the ministry for coping with improving the rehabilitation of the system. Water management to allocate. Actually, we work very closely with the Ministry of Agriculture Research Institutes and agree with approved water needs for different crops for different water systems. Finally, we have the water use optimization department. Mainly, once we introduce any innovation as we are going to introduce, either to the ministry to apply or even to the farmer, we need to give them a complete economic study to help to sustain such innovations. The institute have 11 workstations and technical research distributed along the country to represent different climate change. First one, as we said, as the subsurface irrigation. This one has been applied in the new area in Wadi Lafoon, where we already test some given pipes and system from the Ministry of Water, and the result actually was very helpful and was succeed. That's why now the process is the meantime, we are working with the farmers themselves within some of the field areas. The results from such using the subsurface irrigation, it gives us some initiatives, what types of crops is suitable for such new techniques. And for example, if we compare the subsurface irrigation with even with the surface drip one, it save about, it improves efficiency by about 10%. And even if we compare it with the normal and the traditional surface irrigation, it save about 25%. As we said, this system is now under test in 2 more acres to test some more hoses. There's 2 types of hoses actually now is under test. One is drip under the surface, and one is leaching from such pipes under the surface. Because there is now, we need to advise farmers and users what is the best such hoses and techniques suitable for their land. Maybe this one is good for heavy soil, and one is better for light soil, and so on. That's why it is now under test with, and we are very close with the irrigation improvement sector. The second technique is now, as we said, evaluating the modern irrigation system in old land. As you know, we now are moving from surface irrigation to modern irrigation. But now, what is the limitation for this, and what is the condition we need to consider regarding this movement, either mainly in heavy soil in old lands? Again, it is not the first season actually. We are testing the system again in 13 command areas in 7 governorates. The result of such using new techniques, drip irrigation mainly in heavy area, it gives us some results, which is, I think it should be considered if we need to expand this condition. Some of the soil has been accumulated of the soils, and that's why there is an additional leaching requirement need to be added to such a drip irrigation system. And so if we are going to reduce such techniques, mainly in old land, we have to consider such leaching requirement. So the NEC at the moment is calculating such amount, and even for different crops, even for different areas as well. One in Kafreshik and another one is running in Zankalun and West and East Belt. The third initiative and techniques is using the solar system to operate both surface and groundwater resources. This project is running very close with the ministries, where we are operating one of our groundwater well using such solar system, and operate either the surface and even the drip irrigation to save energy. At the same time, it is the ministry is to expand such techniques even to be worked for all intakes within each branch canals. The technique has been using in the previous one is now using for such integrated groundwater management to reduce either fish and crop production in the new land. We are working very close within one team from the National Water Resources Center to evaluate the process. This is the 3rd year for such evaluation, and the result is very positive. Actually, the unit of water has been improved. Either before giving the water direct from the well to the land, we have it some cycle within the fish farming, which as you know, we need to change like 30 or 40% from such amount every day to this new with whatever content for nitrogen mainly, and to irrigate such results. We compare the result for different crops. I need to raise here for such sample feasibility study has been done within the National Water Resources Center regarding these techniques. which it is very positive where we can expand it mainly in new land, and I think it might be good to expand in the new project for 1.5 million again. And as you can see, the return, the net return for sugar beet, for example, is very high, which compared with the normal traditional cropping system. The fifth analysis, as I said, is to cultivate wheat. We call it early wheat to cope with the situation of water management within the area. This first one, it is early wheat where he put the seeds in 20 hours. Okay, where he pulled the seeds, and the main point here in this case, he didn't need to more work for his land. Just after finishing his wheat, he can go direct to go for cotton. In normal cropping pattern, he cannot cultivate cotton after the wheat crop. Because of time, maybe we are not going to have such farmer where he is explaining his experience and how he cultivated his maybe that is available. If anyone need, we can send it to him. The second, again for Borg Arab station, where we have cultivate wheat to compare either cooling system and to use rainwater. And even the result was very positive, where we have the yield has not changed because of adding more water. So even one more to get one time besides the rain was enough to have the yield what we need. Just the last one initiative, we are now using the unconventional water. We have the link between cooperation between the Ministry of Water Resources, visited by the NWRC, within the Suez Governorate, and they gave us a new area to test the drainage water with the saline area given. And at the moment, we are doing it in Ghana to reduce such techniques instead of losing such big massive of water with high salinity to be used later on. Finally, as a way forward, once we introduce such modern techniques, I think the way forward now is to try to apply what we can call it a smart irrigation. Okay, now we have modern system. If we add the automation system to such precision irrigation, I think it will be added value to open and deploy the system automatically. And I think it is also time to expand using such renewable energy in irrigation activities, either in surface and groundwater. At the moment as well, we have the new techniques for calculating water requirement using what we call it water accounting system, and using the data gathered by using with help of our research stations to calculate exactly the water needs for each crop. Thank you very much.
Thank you, Mr. Chairman. Good afternoon, ladies and gentlemen. Thank you, Mr. Chairman. Good afternoon, ladies and gentlemen. My presentation title is Research Dissemination Plan Project Investigation for Strategic Research Unit in National Water Research Center. And this photo describes this lab. SRU vision is highlighted of leading and establishing an advanced research related to dissemination. SRU mission is creation of advanced research dissemination plans for both of seawater and brackish water, and training a qualified team to operate such research projects, sharing experimental results with other stakeholders in the dissemination sector, and helping Egyptian and Arabian dissemination community for on-site training together. This map shows the country and regions which suffered from water scarcity. Egypt is one of them, where the average per capita decreased because the rapidly increased population from 1959 decreased from 1,893 cubic meters per year to reach 700 cubic meters in 2012. And it is expected to continue dropping to 534 cubic meters per year by 2030. And it is considered below the international water poverty level. Egypt faces water scarcity by taking many measures. One of them is the construction of dissemination plants to supply additional manufacturing industry sectors. Also, it is expected to reach 67 dissemination plants in Egypt by 2050. Regarding to history of research and development in dissemination, this is the literature review from 1980 till then. The development included plant changes in plant size, standard design, technology uses, and environmental water issues. The obstacles are lack of communication between plant owners, industry consultants, and researchers. Also, lack of communication and coordination between different parties. And this slide shows the reverse osmosis technology. Reverse osmosis technology is the most competitive technique, and this chart shows the ratio for reverse osmosis uses at the world reached to 69%, comparing with the different technologies. So Egypt plans to build RO plants with total capacity 6 million cubic meters per day by 2050. And the dissemination lab at SRU apply this technique. What is the reverse osmosis? This chart shows the osmosis phenomena and reverse osmosis phenomena. Osmosis phenomena is defined as a process of molecules passing through a semi-permeable membrane from less concentrated solution to a more concentrated solution. Reverse osmosis simply is the opposite this phenomenon. By external pressure, we can separate the salt from the saline. Regarding to what is the needs for the research and development in the region with the system, we know the two factors affect on dissemination economy. The first factor is energy and the replacement membrane replacement. So we need to robust against pollutants for the membrane chemicals, disinfections, filtration, regulation, and also to be robust at higher temperature for high part system application. Also, the reverse osmosis technology is sensitive for pretreatment. So we must to study or to understand the physical phenomena for the fouling and also fouling disease. Regarding to energy cost is a significant part of the operating cost. Just need to look at other sources to utilize. like such as thermal energy, gas turbine, solar thermal energy, waste energy, geothermal energy, and so on. And in Egypt, we need to hyper energy to reduce the discrimination problem. This is the research point is suitable for the dissemination lab at SRU. To reduction the overall production cost per cubic meter per day. We have two parts research, for research, chemical parts and mechanical parts. Chemical parts we can include as contribute by usage of eco-friendly and scaling to improve material performance. And we must have to mitigate the fouling or scaling. With mechanical parts or mechanical research can be contributed by energy recovery units and also turbocharger. These are types of membrane. One type of membrane is the spiral wound, and this membrane which used in at the dissemination lab at SRU. Spiral wound membrane is the most economical and effective membrane for RO dissemination, and is the cut of the membrane. We can notice that different layers for semi-permeable layers and also permeable layers. In order to accurately measure the performance of the RO, you need the following equation parameters as a minimum. These parameters represent pressure, conductivity, flow, and temperature. Pressure with feed water, permeate water, and also the price of concentrate water, and as the same conductivity, flow, and temperature. This chart shows the steps with the RO technique or RO technology. RO is very sensitive to pre-treatment, so we can show the different processes with the pre-treatment. After that, the saline water goes to high pressure pump to membrane and to separate the salts from the saline water and get to fresh water for distribution community. Activities and achievement SRU activities and achievement by SRU held several meetings and invited other institutions. This institution, as an example, Excellence Center for Dissemination Water Research, Desert Research Center, also holding company for portable water and sewage mechanical engineering department, American University in Cairo, and recently visited. This other achievement, geographic database for existing and planned dissemination plans, and SRU dissemination regarding Ministry of Water Resources and Irrigation Policy recommended disseminated water for tourism and remote areas. The president of the National Water Research Center directed SRU to implement RO dissemination system unit. These components for the system unit at SRU, traditional mechanical system as any dissemination plant, and advanced components for research at added for this system for research at SRU. Third, monitoring and control system. This is the diagram for the system at SRU, and this is a traditional mechanical system consists of feeding process. We have two tanks, for seawater and brackish water, and the filtration process included sand filters, carbon filters, green sand filters, and the micron filters to remove impurities, iron and manganese. And the third photo shows the chemical injection pumps to push anti-scale to prevent the fouling or scaling. And this is the traditional also regarding to traditional mechanical system. We have two pumps, high pressure pumps for brackish water and one piston pump for seawater, and this is the two vessels also at the desalination lab. And this is the advanced for research. We have three systems: vibration system and aeration system, simulation parameters, vibration and aeration to mitigate the fouling or to mitigate the scaling for the membrane to achieve the objective of this desalination. And this is a monitoring system. We have as a desalination lab as a package of sensors for flow pressure, temperature, conductivity, and these sensors at with the feed water, very big water and saline, and this is screen shows that the recorded and monitoring this sensors. Documentation and online, okay, and this is the monitoring system. This is the new figure capacity. Conclusion: advanced unit for desalination is developed. Reverse osmosis is used for desalination. Up-to-date technology. Brackish and seawater can be used. The unit uses a monitoring system to record the performance. Many parameters can be studied for research purposes: vibration, radiation, inlet, temperature, flush methodology, pressure variation for brackish and seawater. Future work to enhance. This is the work plan for the future to enhance the present one stage design to three stages to enhance the energy saving, recovery. Target to get only 4 pounds price for irrigation. Optimization program application with multiple objective function. Advanced high speed camera to study the size of the bubble and so on. And finally, thank you. And I'd like to thank Professor Khalid Abdelhai for encouraging to achieve this lab. Also, I'd like to thank the scientific research team at the Mechanical and Electrical Research Institute and the Central Laboratory for Environmental Management. Thank you.
And now I'll then you are